Most amazing fifth graders ever. I can say that. It's official. Um, this is a quick video to supplement the activities you have in the numbers file. The numbers file contains 2 weeks of activities, so do not try to crank that out in one day. My suggestion would be maybe do the IXL and the Study Jam in 1 week, and the following week do the Gizmo, or vice versa. But this is just a quick presentation of what your text would look like if we were reading this together in class before I set you loose on the activities. First, I'd introduce the vocabulary to you. The first word is a familiar word. It's force, right? We know a force is something that causes a change in motion. Has to be an unbalanced force, and we'll look at that a little later on in the video. But it causes a change in emotion, a push or a pull. If I had a box sitting on the counter and I gave it a push, I would change its motion. That is my force. Same if I pulled it toward me. The next word is friction. Again, probably a familiar word. The friction is the force that works against motion. Surfaces rubbing together. It's why if Haley kicks a soccer ball, it's going to go, but eventually it'll slow down. She's applied the force, but it would stop moving because of friction along the ground. Mass. Mass is a word that we're using in science, and that's the amount of matter in an object. Please don't confuse that with weight. Weight is the gravitational pull of something, but mass is the amount of matter in an object. So if you go to the moon, your mass, the amount of stuff that makes you up, would be exactly the same, but your weight would be less than it is on Earth because there's less gravity pulling on you. Position. Again, not an unfamiliar word, but when I'm talking about this, position is where an object is located. And we usually would say that in relation to another object. So, for example, if your mom asked you to go get a roll of toilet paper, she might say, it's upstairs under the sink. So there we have the positioning under reference point, this other object of the sink. And finally, the word we looked at a lot last week, the speed of an object, that's how quickly it's moving, or how quickly it's changing position. So those are our words that are really big in the gizmo, and it's what this whole unit is about. I love this word, velocity. When you tell someone you're learning about velocity, it just makes you sound so smart. Velocity is speed and direction. So, speed is something given, say, in miles per hour, right? Most of our signs on our highways and roadways are given miles per hour. If I give you a direction with that, then that changes it to velocity. So if I said the rocket was traveling so many miles per hour upward, there's a direction up, okay? Now I've made that a velocity. I could say something is 10 miles per hour. That's speed. But if I say 10 miles per hour east, now it's velocity. Nothing too crazy with that. It is possible for two objects to have the same speed, but different velocities. So for example, I say a car is turning onto Interstate 77 and it's traveling 40 miles per hour. When will it get to Cleveland? Well, depends on its velocity, right? The direction. Someone could be going 40 miles per hour north, and that would get you to Cleveland. Or they could be going 40 miles per hour south. So the velocity there is different. If your speed or direction changes, then your velocity changes. And we have a word. When your velocity, your direction and speed together, when that changes, I have a new science word, and that's called acceleration, which will be coming up. Velocity, the speed and direction, who's that important for? Right. Meteorologists, air traffic controllers, pilots, they want to know direction of a lot of things. If I told you, same thing, there's a wicked thunderstorm coming in 50 miles per hour. Should you go pull in all your cushions and get out of the pool and run for cover? Not until you know what direction it's traveling. you would need to know the velocity of the storm's movement, and then you might have to act on it. And again, when you change the speed or direction, that is what we call the acceleration. So we've used this word before. You've probably heard this word before and things. I think of acceleration when I'm driving a car and I touch on the gas pedal, okay? Because I'm changing my speed, right? A lot of people call that pedal the accelerator because it's going to make you change your speed when you touch that. 3 ways you can accelerate. You could speed up. That's one way to change your speed. What's another way to change your speed? Right. Slow down. That's an acceleration. Oops, I gave you 2 right there. Slow down. Even though a lot of us will call that a deceleration, that's not wrong to say. We would say there are 3 ways to accelerate. Speed up, slow down, and then the one that came out, and spoiler, change direction, turning your car, going a different direction would also be a way to accelerate. So I want you to look at this scenario and tell me if you are accelerating. Remember, accelerating means your speed or direction's changing. You are riding your bike at 9 kilometers per hour. 10 minutes later, your speed is 6 kilometers per hour. Are you accelerating? Ding, 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 ding. Yeah, why are you accelerating here? You slowed down. Your speed changed, right? You went from 9 to 6. Okay, you ride your bike around the block at a constant speed of 11 miles per hour. So since I've told you constant speed, I'm not slowing and I'm not speeding up. Am I accelerating? It's constant speed. I'm riding the bike around the block. I am accelerating, ding, 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 because of what word? Around. That implies you're turning, and then I'm changing my direction. Last one. Oops, there's my little... You are riding your bike in a straight line at a constant speed of 10 kilometers per hour. Are you accelerating? Is your speed changing? No, it's constant. Is your direction changing? No. So are you accelerating? Ding, ding. No, you're not. All right, moving on. I just want to touch on this energy, potential, and kinetic. You know, energy is the ability to do work. And whoops, I did not mean to go back out of there, but it's going to go back. Potential energy is stored energy. It's something that is not moving. If there is a bicycle sitting atop of a hill, it has potential energy. It may not be moving at the moment, but it has the ability to move the stored energy. And with a force, right, with a little push, then I can put it into motion. Kinetic is that. That's energy in motion, okay? So moving energy is in motion. It's kinetic. And if it's still, we say it's potential energy. Where would the most kinetic energy be on this roller coaster? Probably like right here down the hill, right? I would agree with you. And that's the most kinetic, the moving energy. Where would there be the most potential energy? If you've ridden a roller coaster, you know you get to that little point right here at the top. You take that roller coaster and that car gets to the top, there's this little stop. And all of a sudden, then you start going right there, that little hesitation, that's your potential energy. Okay. Likewise, can you tell me somewhere in this roller coaster where there's an acceleration? Well, it slows down as it goes up a hill, right? It slows. It probably or definitely speeds up when it goes down a hill. And where does it turn? Yeah, that's a really good example of an acceleration right in here. As it's changing direction, it goes upside down. So it changes your direction. Okay. There's your potential or kinetic energy or moving energy again down the hill. And the stored or potential energy would be right there, that moment at the very top. So lastly, forces. They are a push or a pull, and they can cause a change in motion if they are unbalanced. So I want you to think about a time that there's a force, but there's not a change in motion. Are you sitting in your chair? Are you sitting in your chair? Your body is pushing against the chair, and guess what? The chair is pushing back up on you. But is there motion? Is your chair collapsing? Is it rising? No. That's a balanced force. If it's an unbalanced force, then there's going to be a change in motion. Okay? Pushes or pulls. What are some other forces you know? We talked about gravity. If we were doing our rocket cars, we would talk about drag or air resistance, right? Those are some other forces. And friction is another. Those are all other forces too. And all of these can cause a change in motion or shape. Well, friction, air resistance, and drag definitely causes a change in motions. Those tend to slow, and gravity, right? Those all tend to slow something down. So there's your change in motion with those. Slowing something down. It can cause a change in shape. When is that? What if I had like a soda can and I squeezed it really tight? Yeah, then all of a sudden now it used to be a cylinder can and now it would be all smashed up. So that could cause a change in shape with a force. And that would be unbalanced. I'm applying more force than that can push back on me. If the forces are balanced, it's equal. Stand up, push against your wall, wherever you're standing. Push really hard against the wall behind you. Are you going to move it? No, because whatever force you're pushing on, that wall is pushing back at you, and it's not causing any motion. All right. I think you'll be good to go with the study jams and the gizmo. All right, kiddos. I'm so proud of you. You're amazing. Thanks for listening to the video. Bye. Oops. One question. I forgot I had that. Force and mass. And I just said that. The bigger an object. This is the last thing. This is what your gizmo is. How do you think force and mass relate to each other? If we were in our classroom, I would put, say, Avery in my desk chair, and I'd give her a push, and maybe she'd go 15 feet. And then I would sit in the desk chair, and I might say to you, give me a push, same force. How far am I going to go? Right? Probably she's either going to have to push really hard, harder than I did to make me go that far, or if she pushes with the same amount of force, yeah, I'm not going to go very far at all. So because of mass, the more mass something has, the more force that's required to move it. All right, now I'm done. So thank you again for listening.